So when we try to solve an integral that we don't intuitively find a solution of, we use the table that we've already discussed before, and we try to find a similar form to the one that we have in our exercise. For instance, here we have 3x squared minus 5x 3x to the power 4 minus 5x squared plus x. This is just the sum of functions, right? So I go to my table and then I find the integral of the sum is just the sum of integrals. This means that I can rewrite this integral here as the integral of 3x to the fourth minus integral of 5x squared plus the integral of x. And I shouldn't forget this dx that needs to be put here. Then I look at each integral separately. What we have here is that we have integral k 3 times x to the fourth. 3 is just a constant, and then x to the fourth is a function. So I go here, and then I find that the integral of k times f of x is just k integral of f of x. So I can just write 3. I can just write 3 integral of x to the fourth dx minus 5 integral of x squared dx plus integral of x dx. Now I go back to each integral again, and then I look at this one. We have x to the fourth is just a power function, which is here. So what we usually do with power functions is that we need to add 1 to the exponent and divide by the same number as the exponent. So we'll end up with something like x 4 plus 1 over 4 plus 1 minus 5 times x cubed over 3 plus x squared over 2, and then we can just go here and add the constant c. It's just the constant that we get from c, it's just the constant that we get from here and here and here. It's just c. So this is our function. Then we'll end up with 3 over 5 x to the 5 minus 5 over 3 x cubed plus x squared over 2 plus c. So this is the solution for the integral that we had earlier. So what's the most important thing to remember when trying to solve an integral is that whatever function I have, I need to rewrite it as functions that I already know the solution of, looking at the table. That's why this table here is very, very, very important to learn, because you will need it in every part of this chapter. So earlier, when you tried to solve the integral that we had, we found that it was 3 over 5x cubed minus 5 over 3 over 5x to the fifth minus 5 over 3x cubed plus x squared over 2 plus a constant. We didn't have a solution or a way to find this constant here because they didn't give us additional information about the function. However, in this example, they asked us to find the general solution for this function here, and also find the particular solution that satisfies the condition f1 equal to 0, which is an initial condition. What they mean by the particular solution is that they want us to find the c, which is the constant that we were omitting before. So because when you give c a value, you are finding one solution of the many solutions of antiderivatives. And in this case, they want us to find one of two solutions using this initial condition here. So what we can do is that we can rewrite we can try to solve f prime of x equal to 1 over x squared. So let's go and do that. F prime of x is equal to 1 over x squared. So we can rewrite this as what we are trying to find is the integral of 1 over x squared dx. This can be rewritten as the integral of x to the power of minus 2 dx. Then this is just a power rule. It will just be, or it's going to be x minus 2 plus 1 over minus 2 plus 1 plus a constant c, which is equal to x minus 1 over minus 1 plus c, which is also minus 1 over x plus c. This is the general solution for this function here. Now we want to find a particular solution for the function. What I mean by that is that we will try to find this c here. To do that, we'll go back to the function, and then they said that f of 1 will be equal to 0, and f of x, we found that f of x is minus 1 over x plus c. So what we'll just do is that we'll do f of 1 equal, or let's try to do that in another page. So we found that f of x is equal to 1 over x minus 1 over x plus c. And now we are trying to find c. What we have is that f of 1 is equal to 0. So what we can do is that we can replace x by 1, which will give us minus 1 here, plus c. And then we can put, since f of 1 is equal to 0, we can put minus 1 plus c equal to 0. This will end up giving us that c is equal to 1. And this will end up giving us a particular solution, which is f of x equal to minus 1 over x plus 1. This is the particular solution for f prime equal to 1 over x squared, which is the function that we needed to find the solution of.